Climate change is a reality, and as caretakers of the planet, it is our duty to do something about it. While there is no single solution, carbon capture and sequestration will play a major role. For many hundreds of years, average global temperature has changed very little. Since industrialization less than 250 years ago, it has risen by 1.4 degrees Fahrenheit, and this trend is set to continue. 1.4 degrees may not sound like much, but the consequences are enormous. Ice caps are melting, extreme weather conditions are on the increase, and damaged ecosystems are endangering the livelihood of millions of people. And this is just the beginning. It is now widely accepted that greenhouse gas emissions from human activity are the major contributor to climate change.
Climate change is a bit of a shock to us all, because we look at the planet and we say, it's so much bigger than we are, how could we be changing anything important? We're pulling carbon out of the ground as coal, oil, and gas, and it's going into the atmosphere after we burn it. It turns out that the carbon dioxide that is being added to the atmosphere is changing the climate. We are actually disrupting our own lives by our own actions.
The combined burning of fossil fuels for power generation and industry is the biggest producer of man-made carbon dioxide, or CO2 emissions, in the energy sector. There is overwhelming consensus from scientists, environmentalists, and elected officials that we must do something to address the problem. In some parts of the United States, new laws have been passed to encourage a reduction in greenhouse gases, especially CO2.
There are a range of things that one can do. Energy efficiency, conservation, land use changes, behavior changes. Renewable powers, winds, biofuels, many different things can be done, and we should be seriously investing in all of them.
Although these measures will help to reduce CO2 emissions, a complete transition to renewable energy will take many decades. However, the United States, and indeed the world, continues to demand more power, and this requirement is set to almost double by 2030.
Solar energy is very expensive. Wind energy, though abundant and not so expensive, we're just learning today how to integrate these sort of intermittent energy supplies into our grid systems.
Until power supply from renewables can meet our ever-increasing demand for electricity, fossil fuels will remain a major source of fulfilling our increasing demands and will still provide more than half of global energy supply in 2050.
Even if we maximize the use of renewables and efficiency, which is something we believe is vital, we will still have some degree of use of fossil fuels in our energy mix for quite some time. Whatever the role of fossil fuels will be in the future, it's vital that we find a way to take care of its CO2 emissions.
Not only are 40% of the carbon dioxide emissions at power plants, but they are the places where it's probably easiest to do something about the carbon emissions. At a power plant, you have millions of tons of carbon dioxide being emitted in a single year in large pipes at high concentration, and you can capture that carbon dioxide at much lower cost than in the 60% of the carbon dioxide emissions that are dispersed uses.
This process, widely supported by many scientists, environmental organizations, policy experts, and energy businesses, is known as carbon capture and sequestration, or CCS. It involves capturing the carbon dioxide, or CO2, associated with the combustion or conversion of fossil fuels and preventing it from being released into the atmosphere where it contributes to climate change. The CO2 can be transported via a pipeline and stored safely and permanently underground in the type of rock where the carbon originated. CO2 has been pumped underground by the oil industry for over 30 years, with over 500 million tons having already been injected into U.S. oil fields.
We know a lot about injecting carbon dioxide into the subsurface. In Texas, in the United States, CO2 enhanced oil recovery is a major portion of the oil that we're producing in that region today. So yes, it's a new technology, but we have nearly 30 years of experience of analogous technology in CO2 enhanced oil recovery.
Estimates of global CO2 storage capacity are up to 10,000 billion tons.
If we look at the U.S., there's an estimated to be over 3,000 billion tons of capacity here alone. So what does that really mean? Basically, it's a big number. We have hundreds to many hundreds of years worth of CO2 storage capacity if we took all of the emissions from fossil fuel-fired power plants and injected them underground into these storage reservoirs.
Mature oil and gas fields are ideal for sequestration. Saline formations also have tremendous potential. A number of demonstration projects have been conducted over several years around the globe. These same geological rock formations have trapped natural gas and oil beneath the earth for millions of years. Let's look at the technology in a bit more detail. The captured carbon dioxide will be compressed and transported via pipeline to a suitable geological formation. For sequestration, the CO2 is injected more than half a mile down where the subsurface pressure maintains it as a liquid. When injected into the reservoir rock formation, the CO2 tends to rise within the rock as it is lighter than the surrounding fluids. Over time, several trapping mechanisms maintain the CO2 within the rock. During its migration through the reservoir, some residual CO2 is trapped between the grains in the rock. Eventually, the CO2 will rise to the top of the formation, where it is physically prevented from rising any further by the cap rock, a naturally occurring impervious barrier. Gradually, much of the CO2 will dissolve into the host fluids, whether they be oil or salt water. This dissolution causes the fluid with the CO2 to sink lower in the rock formation, where over millions of years it will react with naturally occurring minerals to form stable minerals such as calcium carbonate. Once in this form, CO2 can never re-enter the carbon cycle, making certain that CO2 sequestration is safe and ecologically sound.
Is CO2 actually safe underground? Absolutely. That involves choosing a good site and operating it well, but CO2, we know, has been held underground in natural formations for hundreds of millions of years. The crust has mass, the crust has strength, and it's well suited to hold CO2 if you choose a good place.
In many oil fields, the CO2 enables previously unrecoverable oil to be produced. This enhanced oil recovery process can increase the amount of oil that might be recovered by up to 15%. A wide range of subsurface monitoring techniques can be deployed to track the migration of the CO2 within the rock and ensure that there is no leakage. A program of tests will be conducted before, during, and after injection of CO2 into the geological formations. All pipelines transporting the CO2 are also stringently monitored. Safety measures include automatic emergency shutdown valves at regular intervals so that in the unlikely event of a leak, sections of the pipeline can be rapidly isolated.
In the U.S., there's about 3,500 miles of high-pressure CO2 lines. One must take advantage of any right-of-ways that already exist for a CO2 pipeline, streets, utility lines, railroads, and the like. CO2 is not a poisonous substance, and it's not an explosive substance, so actually it's much safer than many of the products that we pipeline.
CO2 is non-toxic, but could it pose a threat to the potable water table or the greater environment?
CCS should not be a risk to groundwater. CO2 is normally emitted from the roots and leaves of trees and plants, so it's present in the soil zone at quite high concentrations. Most living things and most groundwater systems are tolerant to variations in CO2 concentration.
So why do we need to act now?
By the time my daughter graduates from high school in just 15 years, she will be living in a world where climate change is real. It will mean less water in the state of California. It may mean we write off very large coastal assets like New Orleans or Miami. The potential impacts of climate change are enormous, and we've already begun to see people who are migrating because of climate change. We've already begun to see habitats that are lost.
where carbon dioxide capture and storage is so important is we're going to produce a lot of energy in this country, and we need more low-carbon options so that a larger and larger fraction of what we build and use, and not just in this country but around the world, is a low-carbon power. I don't have any doubt that we're going to build power plants. The question is, are they going to be clean ones?
While there's no single answer to solving the problem of climate change, carbon capture and sequestration is a vital part of the solution. Increased efficiency and a switch to renewable energy sources is vital, but while this transition takes place, we will continue to rely on fossil fuels to meet the increasing global demand for power over the next century. CCS could provide us with a quarter of the solution in combating climate change, and the technology is available now.